An experiment consists of tossing a fair coin twice. The student reasons that there are three possible outcomes: two heads, one head and one tail, or two tails. Thus, the probability of getting two heads must be 1/3, because there's three different things, right? Either you're going to get two heads, you're going to get one head and one tail, or no heads, both tails. So there's three different things that can happen. So the chance of getting both heads is 1/3. What is your reply? Is that true reasoning? Well, what's the real situation when we toss a coin twice? You could do it with a tree. You could say, well, we get heads the first time, tails the second. That's a half chance for both. That's the first flip. And then the second flip is also heads or tails. Second flip. So putting that all together, we have heads, 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 tail, tail, head, or tail, tail, and I forgot to put the half on each of these heads and tails. So there's actually four things that can happen. The mistake that child is making, the student is making, is they're lumping these two middle ones together, but they're actually different results. Head coming first, followed by tail, or vice versa. So the order there matters. And the probability for each of these is a half times a half, which is a fourth. So the probability of heads, heads is a fourth. So our answer is C. The student is wrong because although there are three different outcomes, the outcomes are not equally likely. You can't do it that way. There's two ways to get one head and one tail, these two ways. So the probability of two heads is 1/4, as the table shows us. So it's always best just to lay out the table when you have two actions. First flip, second flip. Just lay out the table and you'll find the answer.